So today we're talking about maintaining Windows 10. So maintenance. Maintenance basically means that we do things to prevent problems from happening. Okay. So the things we're going to talk about is actually updating Windows 10. That's really important from a security point of view as well as a functionality point of view. So let's quickly talk about that. That one is actually monitoring Windows 10 with some performance monitor. Okay, so let's talk about updates before we even get into how we do the updates. So we all know that, as soon as you write a program or as soon as you do something, even my worksheets and PowerPoints, as soon as I put it down and put it on the learn side, I realize I probably made a mistake. And I'll probably have to fix that for next time. So we do, because there's always mistakes, there's always bugs, there's always problems with anything anyone produces. So the thing is, if it's just a PowerPoint, no big deal. There's a typo, no big deal. But if it's a problem with your operating system, problem with your program, that could lead to issues like someone else being able to use that problem to actually compromise your system. Like classic example of something like that is the buffer overrun attack. So if you've ever heard of that, that's where, if you've never heard of that, basically there's this thing called memory, which is RAM, right? So basically when our operating system loads, it actually loads a whole heap of stuff from the physical hard disk into memory. When it's in memory, that's where the CPU and the rest of the programs are interacting with it. Okay, let's just say that this computer loads the user database or their passwords and all those credentials into memory. Okay, so it's stored somewhere in there in memory, and every time someone logs in, it compares your login to that thing that's stored in memory. Okay, what's that got to do with buffer overrun? So basically, when someone creates a program, they define in memory that this is a type of data that's going to be stored. Okay, so if you've done any programming, you might define a integer, what's a memory location. You might define a ASCII. You might define whatever type of memory storage for variables. Okay, heard the term variables in programming? Yep. So that's where you store changing information. But the thing is, if I am creating a program and it tells the user to input their email address, for example, okay, that's no big deal, but I'm going to store that in memory now so that I can use that email address in other parts of the program. When I said to create a new email message based on this email address that's stored here, right? But obviously a sensible person will sit there, just type their email address, no problems there. It's going to work. But what if you're not a sensible person? What if you're just this guy who wants to see if they can break your program, website, whatever, that uses this memory? So instead of typing a usual email address, what if I just typed in 6,000 characters? You get me? So no one's going to type in 6,000 characters, but what if they did? And you've just defined this size for your memory, for your variable, this size. That might fit like 256 characters, but someone's typed in 6,000 characters, meaning it's going to go over that size, isn't it? So if you don't have any error correction or error checking mechanisms in your program, which says this is ridiculously long and this is not a proper email address, the person will be able to do that. But the computer, not being a smart person, is not going to say this is wrong by itself. It's going to just try to store that into this area memory that's set aside for this purpose. But because it can't fit all of that 6,000 characters in, it's going to run over to the next part of the memory. That's why it's called a buffer overrun. So it's just going to write it, it's going to keep on writing, but if it runs over the next part of the memory, that next part of the memory could be storing other things. What if it was storing your username, passwords in memory in that location? Okay, so if I was a clever enough attacker, couldn't I just put in information into that thing so that when it overruns the enough memory, it actually puts in the exact information that will represent an administrator with a password of password 1 into that area of memory where it's being used to store our user authentication information? You see what I'm getting at? If the attacker can use that problem in your programming to actually write into memory wherever they like, they could potentially compromise your system and give themselves administrative access. Okay, that's all hypothetical, but it has happened in the past. It has happened in the past, and that's what's called a memory overrun attack. Okay, so if you like a little bit more, okay, buffer overflow. Sorry. So if you want to read about it. There's plenty of it, stack-based exploitations and etc. So you can actually have a look for yourself if you're more interested. So basically, if I wrote a program like that and there was nothing else to sort of stop me from doing that, I could have just created this big giant security risk to the operating system I installed this program. This could be some silly little program that gives you like a emoticon or something like that. And now you've got this giant black hole of a security risk to your computer. So, but obviously as a programmer, if I wrote that and it was identified to me as a problem, I wouldn't want to just leave it as a problem, would I? Or even the Windows or operating systems or whatever wouldn't want to leave that problem open. So maybe we want to create a patch or fix or update to that program that fixes that problem. So therefore, we have to keep our Windows operating system updated regularly. Okay, the easiest way to configure your computer to be safe is to make sure you keep up with your Windows updates or security updates. Make sure you have your antivirus with all the signature updates. Make sure you have a firewall, which is actually secure, blocking off traffic from coming to your computer. And then you're relatively safe. Not completely safe necessarily, because there's always something that we don't know about. And that's the problem with the internet. There's these things called zero-day attacks where no one knows about it until they happen. Okay? So it's very important to stay updated. Okay, so talking about updates, how do we service Windows 10? So there's actually a Windows 10 servicing model. Okay, there's a current branch, which is a application feature updates available immediately after publication. Their availability, all the main editions of Windows 10 are available. So that's the current branch. There's actually a current branch for business, which is feature updates are available approximately 4 months after the publication. All editions of Windows 10 except for Home Edition are applied. This is applicable. And there's a long-term servicing branch, which is a long-term deployment of selected Windows 10 editions with minimal feature updating and only available to enterprise long-term servicing branch servicing options of Windows 10. And this doesn't really make sense to most of us, I don't think. But basically, these are free servicing models based on how you want to manage the updates. So for all of us, especially the home user, we are under the current branch. So this means that the features are immediately available to us, to our computer, if they're important enough. And this is for any edition. This current branch for business is really the business taking active role in managing this updates. And that's only really for business, as the name suggests. And the long-term service branch is really for these networks where the computers are sort of offline. They're not actually connected to the internet or connected to other networks. They're actually designed to be working offline. And basically, they don't have to be updated as someone who's online every second. Okay, don't forget, the more you're online, the more you are at risk. The easiest way to be safe from everyone is to disconnect from everything. But that would probably stop functionality of your computer to the level you want to use it for. There's always a balancing act. Okay, so Windows servicing options, Windows 10 update types. There's feature updates. These are full builds of Windows 10, such as the Windows 10 anniversary update that was released 2 or 3 times a year. So if you remember, we talked about that version. So if you remember, we actually had a look at the version. So if I go to my computer and type in, hit the Windows key and type WinVer, which will give us our Windows version. If you look at this version number up here, so I'm not sure if you guys can all see, mine is 1809. That actually means the version of Windows 10 I'm using, or we're using here at TAFE in this classroom, is actually from 2018 September release. Okay, if you, my friend Brendan's got that. Can you do a WinVer for me? Yes, do it for me, and I bet you yours would be 1909 or something like that. Yours is 1909. Yeah, so basically, if you remember, towards the end of last year, we had this giant update, and it took ages to actually complete. It was basically your operating system completely being upgraded from the previous version to that 1909 version. So if you haven't heard it, if I haven't mentioned already, Windows 10 is the last version of Windows operating system that's ever going to be made. Not to say there's never going to be upgraded or updated, it's just it's going to happen like that. Even if you take a Windows 10 that you created 2 years ago, you put it on the internet, you will soon get to yourself to the 1909 version, which includes all the new features, new way of doing things, and hopefully all the updates. So these are the feature updates that we're talking about. So which is actually 2 or 3 times a year, and the last one from my memory was the 1909, which is 2019 September. There's also quality updates. These are cumulative monthly updates, and that supersede the previous month's quality updates. So you might notice that once a month, your computer will, almost once a month, or it seems like it's more often than that, but your computer will be applying some sort of update. Okay, some people call it update, what's it, update Tuesday or something like that, because suddenly all the updates are available on a Tuesday, not Monday, but on the Tuesday, because Monday, if something happens, yeah, everything always happens on Monday morning, doesn't it? Like as in the problems occur on Monday morning, so they try to not put on Monday. So they're often being updated, and they're sort of not as big as the feature update. Not as big as the feature update, but these are updates that has been cumulative over the last month. So how can we update our Windows 10? Okay, so what we have right now, everyone's computer is going to automatically want an update. That's by default. Okay, obviously, if that's the default action, it means it's more likely to be secure than not. But by default, every one of our computers will want to update from the internet. And that's fine for us at home, because we've only got 1 or 2 computers at home. That's fine. That's where you get your updates from. But if you look around you in this room, and this is a classroom here at the TAFE campus, you'll see there's at least 20 in this room. And if you think about how many classrooms there are on this campus, there's literally thousands. And if each of those computers needed to go to the internet and download 4.5 gigs of updates, like a feature update, you can imagine how many gigs and terabytes of data that might result in downloading. So there's actually, for a network like this, there's more ways to update the computer than setting it as a default action to update from the internet. You can apply application updates and operating system updates in several ways. One of the ways is manual, which is part of a reactive maintenance process. So reactive sounds not as good as proactive, does it? So reactive really is after the fact. Proactive is before the fact. So manual is possible, but it's not necessarily the best way. There's automatic, which is better. And with the automatic, there's a couple of ways. We can use the Windows Update, which is go straight to the internet. We can also use the System Center Configuration Manager and Microsoft Intune to deploy these updates to the computers. Okay, this is more of an organized way where we can actually deploy updates to all these network computers instead of relying on them each to go to the internet and get their own updates. You can go back to the previous version up to 10 days after the upgrade. You remember how I said it's always good to update, but there's a thing in IT as well. Don't be the first. Don't be the first, because sometimes, I'm not sure about you guys, but sometimes when you apply an update, there'll be unintended consequences. Okay, for example, one time we were using, if you've done counseling with us, you notice we use that Excel spreadsheet to do our counseling and help us counsel. One time there was an update. It turned on some protection on Windows Microsoft Office, and as a result, the macros that we were written for that program didn't run properly because it was obviously disabled them. And we didn't know about this until we sat in the computer room with a student next to us and we wanted to counsel them, because these updates were deployed to the classroom computers, not on our desktop computers for the lecturers. So it was running fine before we got into the classroom, but when we got into the classroom, it had updated and we couldn't run it properly. Okay, so there's always unintended consequences to your updates sometimes, and the general rule is don't be the first, and always do your testing if you're going to roll it out for your whole network. So let's have a look at how we update our computers. I'm going to go to my Windows 10. It's turned off. It's possibly because I haven't done anything with it for a while. Okay, so if I log in, so obviously if we're going to let this computer update, it has to have internet connection if it's going to do it manually. All right, so in order to update this, to be honest, this Windows 10 is a little bit outdated because this is from, so if you remember, I typed Winver. If you look at this, this is one of the Windows 10 build 10.2.4. This is probably one of the first when Windows 10 was first released. And because it's a virtual machine, we never updated it because, well, what do we need it to do? We just needed to work in a lab and to work consistently in the lab, and thus far we don't need to update it. Okay, so that's why this computer is like that. But it means that everything that we see on this computer might be slightly different to what you see on the latest version of Windows computer. But if we go to settings, there's this update and security area, and if you look at Windows updates, you can see that, whoa, this computer's got a fair few problems because it's trying to update a Windows that was probably, I don't even know how long, 4 or 5 years old, with all the latest updates, because every time we put it on the bridge network, it's going to try to update. From here, we can actually look at the advanced settings. We can obviously choose whether it's automatic. How would updates be installed? Automatic, or notify to schedule restart. Or you can also check this box which says give me updates for Microsoft products when I update Windows. So if you're not sure what that means, it means that, don't forget, on these computers we have, besides Microsoft Windows operating system, we also have all sorts of Microsoft products like Office, etc., and we can update Office in a similar way. We can also choose to defer upgrades. So the upgrades is where we talked about the feature packs, where we're doing major updates. We can look at our update history. Oh, you can see this computer, when I put it on the bridge network, when was it that I first put it in the bridge network? Looks like February the 20th. Sorry, February 28th. Before that, it was February 2017. So basically, I reckon that was when I created this virtual machine to be used in our labs. Okay, so you can see that based on that, the last time I turned this computer on before I created the virtual machine was February 2017. Then we used it in class on the February 28th. I probably restored it to a snapshot. And then it was trying to apply these updates and obviously failed. And this is probably because this virtual machine is failed. Let's go to my real machine and see if I can have a look at that. Windows updates, it's up to date. We can view the update history, and this should be a little bit better viewing. There's quality updates, which are these ones. Definition updates. and it's good. Okay, so when you have problems, you have successful or failure. Obviously, with these updates, you want to be successful. Failures means that something's gone wrong. Okay. So you can, in this picture, this showing you that it's just applied an update. It needs to restart the computer, which often happens. And obviously, if you don't want to restart your computer right this second because you're doing work, you can reschedule it, or you can just restart it. This is what I was talking about before. This is talking about you can update other Microsoft products as you update Windows. And you can also defer the updates, feature updates, which is the upgrades. You can also complete the, how you need to restart, you need to turn on, then it needs to finish off. You can actually, if you check this third box here, you can actually use your credentials, current credentials, to finish the update process. If we look at the update history, you can see when things were installed. And let's just say the last update caused you a problem. We can go to Control Panel. We can go to Programs or Uninstall a Program. And we can actually view installed updates here. Oh, here's the update for Adobe Flash Player. Okay, I'm just trying to work out what's safe for me to play around. So this was a security update, but I realized after this security update, my whole system was broken. Didn't work, caused some unintended problems. So I could just uninstall this particular update, and hopefully that resolves the problem. Okay, so these updates, sometimes you can't. So with those feature updates, you can't actually, once you've done it and it's past the 10 days that we were talking about, so you can go back to previous version up to 10 days after the upgrade. That's sort of good. But if you wait after that, you may not be able to go back to the previous state. Okay, so Windows, so let's keep on going. So we can view it in our control panel, and we can uninstall it if we need to. Choose how updates are delivered. Basically, updates from more than one place. Download Windows updates and apps from other PCs in addition to Microsoft. This is, if you don't know what this means, if we're in a network of computers, and if we're all downloading the same updates, and we're all getting it from the one source, which is Microsoft updates on the internet, and millions of other people are, it's going to be very congested, isn't it? So this part where we turn it on, it's really a bit like Bittorrent, if you've ever used Bittorrent for legitimate purposes, of course. But it's actually saying, this PC, once I've downloaded a bit that I need, I can actually make that bit available to everyone else who needs it. So instead of everyone downloading all the bits from the one source, it's going to get a little bit here, a little bit there, but it just means it's quicker because it's not all getting it from the one source. It's like, if you like to think about it, it's like when we go to McDonald's and if we all have to talk to the same server at the counter, we have to take our turn. It's slower overall, but if we could all place our orders at the same time, we could actually do a lot faster, couldn't we? So basically, if we turn that on, that's what it means. And here, this is where you can actually, this is a choice. You can only, if you want, you can send only updates to your people on your local area network, or this other option means everyone in your local area network plus the internet. I would be a little bit skeptical about the second option, because if I'm sending things to the internet, it's people on the internet. There's literally millions of people who have Windows, right? So potentially I could be clogging up my WAN link by uploading updates to other people on the internet. Whereas to the local area network, that's not a big deal. That's LAN. It's not utilizing the WAN link. It's the LAN speed is gigabit, and when my computer's not using it for other things, it could be updating other computers which are important to me anyway. Oh yeah, if you do, definitely. Especially if you have limits on quotas or stuff on your downloads, internet downloads and uploads, probably more uploads than downloads. then you could potentially be just seeding for millions of people from your computer. And seeding is a BitTorrent term, obviously. It means you have the part that people need, okay? We used to actually use BitTorrent to deliver the virtual machines to each of your computers here. We set up a BitTorrent server, huge file. So when you download it, instead of downloading from the IT Study NAS from one go, you actually get the virtual machines as little bits from each other. So yeah, that speeds up the whole thing quite a bit. Sorry, what's that? Oh, well, the technology is not bad. It's how people use it, just like any file sharing. Yeah, any file sharing technology. Yeah, exactly. If your computer happens to be in an Active Directory domain, like a network with Active Directory servers, then you can actually configure the updates using your group policy. So instead of you, as administrator, going to every one of these computers and configuring your settings that you wanted, you can actually push it out through group policies. And like I said, in this subject, we're not looking at the domain at all. But in the next subject, via ICW, we'll start looking at the domain. And one of the topics in that subject would be WSUS server. Okay, that's Windows Security Update Service, which is what we're going to talk about next. So in that subject, not in here, but just be aware that this is possible. Instead of actually getting all our updates for all of these computers, literally thousands from the internet, we are going to have a WSUS server, which is actually going to be downloading all the updates once, not just for itself, but for every product that you want to include. Office, Windows 10, Windows, whatever version, Server 2019, whatever. It's going to have all those updates as a local copy here. Then, you know what? The best thing about this WSUS is that I don't have to deploy it all on all the computers all at one go. Remember I said don't be the first? Adequately test it? Well, we can actually set up a group of computer called test clients, and we can say apply updates only to test clients. So those new updates that we just talked about is only applied to these test clients, and then we can inspect the functionality. Does everything still work? Is there any problems I should know about? And if there is a problem, you know what? The good thing is I haven't actually deployed it to the actual computers, have I? The actual production computers. So no problems at all. So I'll have to investigate how we fix that problem before we actually release it to everyone else. So once we've tested correctly, then we can actually apply these updates to the other computers on the LAN. And we can do a staged approach as well. We can say that this orange group gets it first, then the green group gets it, and do it however we want. Basically, we control the updates from the server rather than each computer taking care of itself. So Windows Updates for Business delivers updates differently than WSUS. So this is another way. So the Windows Update for Business, you have what's called distribution rings, and we can defer updates. Quality updates can be deferred for up to 30 days and pause for up to 35 days. Feature updates can be deferred for 180 days and paused for another 60 days. And drivers can be excluded from the updates. So drivers can even be part of the updates. So this is more like that small business server that we're talking about, okay? But we can actually do all of those things. We can also can define maintenance windows. So sometimes we don't want updates to happen when Microsoft says they should happen. We don't even want them to happen between 9 and 5 for regular business. Maybe we want to do it between 7 and 8 or 7 and 10, whatever you define. Because we could define them as maintenance windows, and we can optimize delivery as well as integrate them into System Center Configuration Manager and Microsoft Intune. So System Center Configuration Manager is another subject we'll be doing further down the track, and we'll be deploying operating systems, software, as well as these updates through a service over the network rather than manually like what we've been doing with the Windows 10. But we've got to start somewhere, right? We start to know how to do it manually first and understand what things are. Then we do it in a domain with WSUS, and then we do it with a configuration manager, which is actually how TAFE SA here does things. Just as a side note, You guys have seen that software center on your desktop, haven't you? You've seen that software center? Here it is. There's the software center. And basically, this software center allows us to look at operating systems, updates, applications, as well as all of these things, and allows us to deploy to computers over the network. And that's through SCCM, System Center Configuration Manager. And with this, we can create computer groups, user groups, and deploy it based on computer membership or user membership or any other combination. So that's coming around in your subjects in the future. All right, so now let's look at troubleshooting. I think I mentioned this before, but the event viewer is Microsoft's Windows logs. Okay, logs. We need to know logs because we need to know what's happening on our computer. So if we look at event viewer, it's on every Windows Microsoft operating system. If I actually click start and I type event viewer, it's our logs. And if we go to Windows logs, we can go to application, which are basically logs to do with the programs. We've got security logs, logs that are associated with logging in, logging out, access control. We've got a setup log, which is, again, as the name suggests, was to do with setup, installation. And we've got the system log, which is probably the most important one out of the lot. That's the operating system log. But if you scroll down this list, it's just things happen and it gets logged. And if there's three sort of icons you can see already on here. There's these white icons with a dot, a sort of eye in it, blue eye. They're informational, so nothing to worry about. These things happened. They're normal things that happen. So for example, this one, if I click on it, it will display the message down here. Initiate installation started. Windows has started installing the following updates. Security intelligence update for Windows Defender antivirus. Nothing to worry about. That's normal. Okay, that's not a problem. That's what should happen. So information, so this information level type log entries, not to worry about at all. Then you got these yellow ones with the sort of exclamation mark. It's a warning. Okay, it's saying warning. There's a thing that happened that could be a problem, but it's not that huge of a deal. So here, name resolution for the name, whatever timed out after none of the DNS servers responded. Well, that could be one of many problems. One is our DNS is not working, which could be a problem. Could be just that name that we try to resolve wasn't even a proper name. But it could be a problem. That's why it's a warning. Then we have these red ones, as the color suggests. Yeah, error level. So if I double click on this one, I can actually see the application specific permission settings for the local activation permission for this COM server. Yeah, to be honest, I'm not worried about this. This is talking about activation for this COM service. But if there was an actual problem on my computer, I might go through the logs and look for these errors. And remember what I said? Here's the event ID. That gives you a number. Oh. Remember what we said before about the Microsoft support page that we talked about in our assignment? In this page, we could actually go event ID, paste it in, the event ID. Oh, look at this, DCOM logged. And if we actually read about this, this is actually the symptoms. It's talking about the application specific permissions. This is exactly what mine said, didn't it? These are the sources. Oh, whoa, here's a cause. Isn't that good? These events are recorded when Microsoft components try to access the DCOM components without the required permission. Yeah, let's say that was actually a real issue on my computer. Whoa, here's a workaround. So if you workaround are not actual, doesn't fix the problem. It just means you get around the problem. It's a bit like a detour on the road. Yeah, this road's got a big pothole in it. They got workmen working on the side. So instead of actually trying to go through that road, you go through a side street. So workaround's a bit like that. So it doesn't have actual fix for it here, but a lot of other problems will have workarounds as well as fixes that you can try. So this Microsoft, we used to call this TechNet, but it's now called support, is actually really good for Microsoft technicians like you guys want to be. Then we have the reliability history. Okay, so let's have a look. Okay, reliability history. If I press start and type in reliability, I can actually look at the reliability history of this computer. So obviously it's a scale from 1 to 10. Obviously 10 is very reliable. So you can see that these are events. If I click on this event, it can show me on this day, 26th of February, these things happened. We did all these things. These events were logged. On the 27th of February, oh, I had a warning from this part. Oh, here's a red one. Remember how we talked about the red errors? We can see that on this day, there was this error. Windows was not properly shut down. You see how that corresponds with that graph dipping here? Obviously, if your computer wasn't shut down properly, that means your computer is probably not reliable. So it dips in the reliability. So this actually, and if I click all problem report, we can actually, it's not showing me anything. Yes, we can save the reliability history and we can compare it later on. Which next brings us to performance considerations. So hopefully all of you guys know that it doesn't matter what operating system you have, it's working on hardware. Okay, so how well your computer or how fast your computer works, or how easily it can handle the tasks you ask of it, depends on the amount of resources. The main ones are processor, disk, memory, and network. So processor is your CPU. The faster your CPU, the more cores it has, the more physical CPUs you have, means the more tasks it can do. The disks, we already discussed this, hard drive. So obviously hard drive, how has that got to do with performance? We know there's a big difference between a solid state hard drive and a physical hard drive, mechanical hard drive, right? And that's because of how many IOs per second it can handle. So obviously if this was a computer and you were doing lots of virtual machining, or virtualization, should I say in more better English, more better, that's probably bad as well. If you're doing lots of virtualization, you have a mechanical hard drive, your computer's not going to perform well. I can tell you that. But by adjusting the disk resource to a solid state hard drive, you increase the performance. Well, memory, that's the RAM, isn't it? The more RAM you have, the better. RAM is that very, very super fast temporary storage, whereas your hard drive is your long-term storage. But everything needs to be loaded into memory before you can actually work on it. The easiest way to actually improve your Windows 10 performance is to upgrade your mechanical hard drive to a solid-state hard drive and to increase the amount of memory or RAM you have on your system. And that should make your computer seem so much faster straight away if you do those two things. But obviously, what if the jobs you're telling your computer to do are more processor intensive? Then it may need to have more CPUs or CPU cores. Or what if the task you're asking your computer to do is relying on the network, like you're uploading videos to YouTube. Okay, if your network is congested, your WAN link is congested, your amount of processor or memory or hard drive is not going to make that better, is it? So it depends on what is the bottleneck. You heard of that term? The term bottleneck. So if you don't understand what that means is that any of you guys gone to the Adelaide Oval to watch football or cricket? You know that before port games they have a big march from Rundle Mall to Adelaide Oval, right? And it's fairly quick moving, but until you get to that footbridge. You get that footbridge and it's really slow to get across. So basically a bottleneck is the part of the journey that's actually slow. So for us to access YouTube, our local area network is LAN speed, which is gigabit minimum. But internet connection at home, maybe it's only ADSL or ADSL 2 or even NBN, but that's all definitely slower than gigabit, isn't it? So if your YouTube is not working as fast as your friend from Singapore, it could be because we got a substandard NBN that was a lot slower than what they've got in Singapore. So that's the bottleneck. So what do we do? What do we do? What do we do if we have something like that? We try to remove the bottleneck. So instead of having a single NBN connection, possibly, you could have two. And you can buy a device such as a billion ByGuard router, which actually can load balance between both NBN or ADSL connections, or do something else. So you could always identify a bottleneck, but just be aware there's always going to be a bottleneck. It's just that what is the most restrictive bottleneck? You want to make sure that's actually meeting at minimum standard. So performance bottlenecks occurs when computer is unable to service the recurrent request for a specific resource. Whether that be processor, disk, memory, or network, depends on what you're trying to get your computer to do. Performance monitoring. So basically, we can monitor the performance and evaluate the workload of our computer. Okay, so let's have a look at some examples of this. So let's use my real computer. So there's a couple of ways of actually seeing this. You've probably seen me do this already. I press Shift, Escape, Control Shift, Escape, and I bring up Task Manager. If I go to the Performance tab, I can see straight away, hey, I can see some performance here. From what I can see here, I can see my CPU, my memory, my disk, my Ethernet, and from my CPU, it's not doing that much. It's not zero, but it's not doing that much. You can see, just from visually, I can see that there's, whoa, all this extra capacity I can use. So that's not a problem. If I look at my memory, oh, it's still got some capacity left. That's what these graphs are meant to show you, okay? If I look at my C drive, the amount of activity is not too great either because my computer is literally not doing much. My Ethernet, again, is 800 kilobits per second. Don't forget these are gigabit network cards. But let's see what happens. Let's see memory. I think memory and CPU, just keep your eyes on those two. Once I start a couple of other virtual machines. All right, so you can see my CPU is just increasing quite a bit now. You can see my memory is going up, memory usage. And you can see my disk activity is going up. That's because it's reading, while it's loading the virtual machines into memory, it's reading out of the hard drive, and memory is increasing, and my CPU increases because it's doing all that processing to do that. It looks like my CPU, my virtual machines are loaded now. My CPU settles down. My disk activity settles down more so, but my amount of memory has increased because, don't forget, we allocate virtual machine with memory, don't we? So that gives you quick at a glance sort of information, not detailed, not super detailed. We can also from here open Resource Monitor, should I say, and that gives you a little bit more information. So again, we've got an overview where we've got the 4 major resources, CPU, disk, network, and memory. That gives us at a glance information, a little bit more detailed than before. We've got graphs here again to graphically demonstrate this. But if I care about CPU, I can go to the CPU tab and see more. See what services are running, how much is being consumed. I can go to memory. I can go to disk. This is the one I go to all the time. I go to disk activity or disk storage, and I look at the queue lengths. Disk queue length is really things that are waiting to be read or written to your hard drive. In virtualization, if you have a slow disk, this will be high. It should be 0 or as close to 0 as much of the time as possible. But I also can run Performance Monitor. And Performance Monitor, I can actually choose what counters I add. So right now there's only percent processor time, and here it is. But I can click the add button and I can actually go, oh, look at all these things. Let's look at memory. You can see there's heaps and heaps of different counters. I can go to memory and I can go available bytes. How much memory is available in bytes? Let's Did I add that in? I thought I did. Let's try that again. Okay, available memory in bytes. I add that in. I click OK. Ah, it's already present. Why can't I see it? I can change the graph from a line graph to histogram. Here it is. This is more about more like that. It's also in red. That's why I can't see it. So I can actually change the color of this one to green. Okay, so this is available bytes. This is CPU, and I'll change it back to. Oh, the other one is the report format, which is numbers, and I can change it back to line. You see the green is right up here. That's why I can't see it. That's how much it's a static line. That's why it's a flat line, unlike the CPU, which is fluctuating. Okay. But obviously, if I actually shut down some virtual machines, I might see it's not making a huge difference to my line, but basically what I'm trying to say is I can add loads and loads of counters related to many, many performance items. And this is where you get a lot more detail. And this is where we can use this to actually create what's called user-defined data collector sets, which means we can actually use the same counters and we can actually monitor our computers and we can save it away, pack it away, and then 6 months' time do it again. In the same method, same times, same period, and same counters, then we can actually compare the performance. So now we've got a bit of a sort of a benchmarking, if you ever heard that term, benchmarking or baselining. The thing is, how do we know something's a problem unless we know what is normal? We all know that if you drive a car long enough, if your car suddenly starts making different noise or different sound or works differently, you notice it straight away, don't you? Even your computers, I bet you, the computer you use all the time, if one day it starts loading a little bit longer, takes a little bit longer, you'll notice it, won't you? I do, definitely. So that's because you're so used to, or you know your computer, your car so well that you can actually feel, today it took a little bit longer. So something's off. What happened? But the problem is, if you have servers, if you have computers, literally thousands of them or hundreds of them, you can't get a feel for all of them. So therefore, having these things to benchmark where you can actually not have a feeling, but actually see there's a difference between this benchmark done 3 months ago and this benchmark which is done today. And we can see there's a linear growth. That could be all organic in the sense that this is how the changing user environment has changed the usage. Whereas if you see just the increase like that, you can't think of a reason why it did that. It might indicate there's actually a worm on your systems or malware or something like that. Or it could indicate some problems, some services that are problematic, some programs which are misprogrammed. They're just consuming resources for no good reason. So having these performance monitoring allows us to actually evaluate a computer's workload, monitor system resources, notice changes and trends in resource usage, and test configuration changes and diagnose problems. And we'll talk more about performance monitor when we get to the Server 2016 or server subject. So right now, get on with your worksheet and have